Hydrostatics 2010, question 9, part B. A uniform rod of length 1.5 meters and weight W is freely hinged at point P. The rod is free to move about a horizontal axis through P. The other end of the rod is immersed in water. The point P is 0.5 meters above the water. The rod is in equilibrium and is inclined at an angle 60 to the vertical. Find the relative density of the rod and the reaction at the hinge in terms of W. Okay, so there was a diagram given, and there's some extra information given in this question compared to the normal rod questions. So we have this right angle triangle with our 60 and our 0.5. So we can now get this length above the surface of the water, and we're told the full length is 1.5. So we can break this question up now into simple form. So we have A and we're looking for H. So the cos of 60 is equal to 0.5 divided by A over H divided by X. So cos of 60 is 0.5. So 0.5 is equal to 0.5 divided by X. So X would obviously have to be equal to 1. So this is 1. And this is 0.5. So let's break that up into equal parts. A nice way to do this question. So if we break this up into equal parts, let's see what we can put on the diagram. We can put W going down through the middle here. Underneath the water, there's 2 out of 6 parts. So W over 3 going down that way. My buoyancy is in this direction. We do have a force here. Did they give it a letter? The reaction at the hinge, we call it R, seeing as they're calling it reaction. The reaction at the hinge is in part 2. And this is the point P. So let's have a look at how this will help us. We have the full length is 1.5. So each of these is, there's 6 parts. 1.5 divided by 6 is 0.25. So each of these is 0.25. Each of these little sections here, 1 of them, 2 of them, there's 6 of them altogether. So our buoyancy, so let's look at our buoyancy. Our buoyancy is equal to W over S, and the W is W over 3 over S. So that would give buoyancy as W over 3S. And my moments about P are going to be my B. Well, how far is B away? 1, 2, 3, 4, 5 of them. So B, which we know is W over 3S, times 5, well, 0.25 is 1.25. Have we anything else going up? We don't, so we just have W going down, so it's equal to W times, and we know W is half away. Is it W half away? Well, it's half the full distance, half of 1.5, 0.75. 0.75. So if we replace B with W over 3S, we should be able to simplify this down. So W over 3S times 1.25, just put the decimal in the right place, 1.25 is equal to W times 0.75. So the W's will cancel for me, give a 1 here. So 3S by 0.75 is equal to 1.25. So that's 2.25S equals 1.25. So S has to be 1.25, the relative density of the rod over 2.25, and there's 0.25s in all of them. How many are in top? There's 5 of them in the top, and there's 9 of them in the bottom. So the relative density of the rod is 5 over 9. So part 2, the reaction at the hinge. Okay, let's have a look at part 2, the reaction at the hinge. Well, what have we got going on? 4, we'll have to deal with our forces here. We have R going up and B going up. So R plus B would have to be equal to W. So are we asked it in terms of something? In terms of W. Okay, so W we will leave in the question. So we have our buoyancy. So R in terms of W, R plus W over 3S. So W over 3 times 5 over 9 would be 15 over 9 equals W. So R plus 9W over 15 is equal to W. So if we bring the 9W over 15 across, we're going to get 15W over 15 minus 9W over 15, which is 6W over 15. And they have a common factor of 3. So 2W over 5 is the reaction at the hinge.